Hello students, so today is a revision lesson about how to gather like terms. This is something that you would have studied while I was away on long service leave, so I'm just going to go over this so that you can sort of catch up, because it is a point where many students get confused, not just because of all the craziness that's happened this year, but just generally I find that students from the past have also struggled with this topic. So it's not a bad thing to come back to it, and I'll try to package the information in a way that you can get the idea perhaps a bit a simpler way. So my objective is to make sure you know the terminology for algebra, for example, terms, coefficients, and expressions, and so on. How can you identify the like terms? And then can you simplify by combining them or gathering them up together? That's what we want to achieve in this little video. So let's go over some of the terminology here. So you can already see, you probably looked on the video screen already, that I've got this and I've got this. I just want to make sure that you are aware that these two are similar, but not exactly the same thing, okay? So in equation, an algebraic, algebraic, maybe if I just specify that, algebraic equation has this inside of it. It's already built in. If there's no equal sign somewhere within it, then it's not an equation. It's instead a expression. So you might say algebraic. Okay, and what is it that makes this an algebraic expression? It's because of we can see the presence of letters is being used. So when there's ever letters involved, that's basically algebra. Okay, so expression, if it helps you make sense of it, I like to think expression is kind of like a math sentence. It's just a bunch of, a combination of words. So here we can see a combination of things all together in a chain. So that will be an expression. Another important word to understand is terms in an algebraic equation. I'm just going to say expression or equation for short. It's just easier. So whether you're looking at an equation or an expression, can you identify the terms that makes the building blocks? Think of them like words in a sentence, okay? In algebra, we sort of have these breakup points. Whenever there's a plus or a minus sign, it breaks up the expression into segments. So here I've got a 7, I've got this bit, I've got this bit, I've got this bit, I've got this bit. So there's 1, 2, 3, 4, 5 terms in this little demonstration. However, I do want to, just make that clear. The way I would actually highlight them would be like this, and I'll show you in the next bit why. What you may notice, I'm actually highlighting the sign in front of the term. That belongs to the term. That bit is super important, even more so when we get to coefficients. So what is a coefficient? It's the exact same expression as I had over here, but I just want to highlight to you, the coefficients are the numbers in front of the letters. So here we got some letters. So the coefficient is the number that's with it. So it's the 8, but it also is including the plus or minus sign in front of it. That is super critical. The sign in front is very important. If you try to do all of these things, like gathering like terms, and you're not aware that this plus or minus sign is included with the coefficient, then you will basically solve everything incorrectly. Okay? So just keep that in mind. What if there is nothing next to it? So let's say this is not a coefficient because it's not together with anyone. Co means together. So this one's not together with a letter, but let me just make up one. So I'll just put a letter C next to it. There's no sign in front of it. That's because there's an invisible number. There's an invisible plus sign in front. And usually, I don't know why, but if a number is positive, let's say positive 4, it's just assumed that means positive. It's only when it's not positive do we actually go to the effort of giving you a symbol to tell you it's not positive. So that 7 in front, that'll be a positive 7. And likewise, this 11 here is positive 11. And over here with the letter B, is there a coefficient? Is there a number together with it? Technically there is. There's an invisible number 1 here. So the coefficient is positive 1 in front of this B. Let me put it to you this way. If I draw, okay, that's supposed to be a car. If I drew a car and I said to you, how many is that? You would say 1. There's a car, okay? It's only when I want to signify to you that there's multiples of them, do I start bringing in coefficients. So if I want to signify more than 1 car, I would put 2 car, or maybe 3 cars, or 7 cars. I start to bring out the coefficient in front. And instead of drawing a car, I might just use an algebraic letter like C. So if I say that, I'm telling you it's actually 1 car. The number 1 isn't needed. It's implied. It's invisible. If there's 2 cars, 3 cars, 7 cars, that's when or if there's negative 6 cars, that's when we start to introduce those coefficients. All right, let me just remove all of that. So here, the coefficient for this term is positive 1, even though that number 1 wasn't drawn in there originally. Okay, so we're good with expressions, equations, terms. I also used to draw this like a caterpillar, if it helps kids remember. So there's little antlers of the having a little caterpillar, and its body segments are separated by these plus and minus signs. So I don't know, it just looks cute. All right, I want to get you to, so we're working our way to gathering and combining which terms go together. All right, I'm going to give you a visual analogy, and I think that will give you the secret sauce, the secret technique to be able to figure it out for yourself, no matter what tricks we may throw at you in exam questions. So you'll have to forgive me, I'm not a sport person at all, as many of my students know this, but I presume this is a game of football of some kind, and it looks like there's 2 different teams here, team yellow green and versus team black. I don't know what these teams are. I don't really care, but what we can see is that people are wearing a uniform, so you know which people belongs to which team. If they belong to, if somebody went onto the field and they were wearing the black uniform, then you know they belong with the black team. If somebody walked into this field with the yellow-green uniform, then you know they must be belonging to that team. That's the trick, okay? So here I've got a little visual. I've tried to draw out these little people with the yellow-green and the black uniforms on. Look, there's a lot of people in the background. I had to sort of call it quits somewhere, but let's just pretend like from the foreground, I suppose, these are the people that I can see in the picture. So for example, this represent that person. This can represent the person that's sort of behind them. This is the guy running in front, or actually maybe in the background there, and then there's another one. You get the idea. So from this picture, we got a bunch of different players here. Now, I did say to you that if they're wearing the same uniform, then they kind of go together, don't they? So if I group all the yellow-green people together and all the black uniform people together, all right, I'm gathering like players. I'll give you a hint. So I could go to the effort of drawing each one of these over and over again, or I could just go say, well, there's 4 of these people who have yellow-green uniforms on, and there are 3 people wearing the black uniforms, at least in the foreground. Look, I know there's more in the background, but I don't care for this analogy here, and I'll just say, in total, I'm adding this number to this number. Now, we're getting closer and closer to what it looks like in maths. So instead of writing yellow-green, instead of drawing yellow-green uniforms, I could just say that as GY. The letter G is for the green part of the uniform. The Y is for the yellow part of the uniform. And then for the other players, I could just use the letter B, and that's going to represent, let me just grab the black color here. That's going to represent the black uniform. So this is our trick. You can figure out, with a uniform, you can see that sometimes a uniform will have many colors on them. So it is very possible that for a single term to contain more than one letter in it, and that makes up the special source, the special combination for the uniform. Now, the whole time I've been saying yellow-green uniform, but I've written this as GY, green-yellow. Isn't that the same thing? If I said to you that this person here is wearing a green and yellow uniform, that makes sense. Same way as if I said it was a yellow and a green uniform. It doesn't matter what the sequence is, so I could swap the G and the Y around and it would still mean the same thing. And here we got these people here. There's only wearing black uniform. Okay, so the rule is like terms are terms with the exact same letter combination. It's the combination that makes up the uniform colors. If it helps, you can use, you can just pretend some of these letters we use in algebra, so like A, B, C, D, and so on. You can just pretend that some of them translates to a color. So like A could be an apricot color, or B could mean blue, or maybe even black. I don't care. C can mean cyan, D for dark, E for Okay, look, it does fall apart around here because I couldn't think of any colors. But then we get back to G for green, and then H for, oh goodness, I was thinking like a haystack, so like a bit of a brownish color. But it might be enough to get you going to figure out what groups together nicely. Let me just hit backspace a bit here. Done. So let's go hunting. I've got 4 of these, and we're just going to go hunting. Within each one of them, do we have any terms that match? Now remember, let's just quickly recap what a term is. So these, remember the little caterpillar? How each body segment is kind of separate from the next one by those plus and minus signs. So here I've got a term there, I've got a term there, I've got a term here. And this one I've got a term there, a term there, a term there. Remember that I'm including the plus or minus sign in front of the term, so that's been really important for the process. Here's another term, here's another term, here's another term, so on and so forth. I'm going to undo this, but you get the idea what we're looking at here. Do any of these terms go together? Are they on the same team? Well, I can see I've got -2 apricots plus 3 apricots. I think these ones belong to the same team. So I would group this term and this term as belonging together because they have the exact same uniform. This one, on the other hand, has no uniform, so they must be some random person watching the game. They don't belong with the team. If we go to the next row down, I can see there's one person with the yellow uniform on. Remember, there's an invisible number 1 in front of any letter. Like remember we did with the car analogy, just one car. We've also got -3 people with the yellow uniform on. And then we got 2 people with no uniform on. So they must be just random people that don't fit. We can now go to the next one down. Now I think I'll use green. So we got 7HG plus 2HG. They both have the exact same HG uniforms on. So those match, and I could gather them together, and I'll show you how that works a bit later on. What about this last one over here, H? Well, it looks like it's got part of the uniform, but not the exact same combination. For example, could you imagine that there might be... Ooh, I'm supposed to be using a lasso tool here. Let me just grab this little guy. Okay. Copy, paste. So I want you to imagine a new scenario. Okay. We've got some people on the field who have a black shirt and black pants, and they are versing against other people who have white shirts and black pants. Are they the same team? No. They don't have the exact same color combination. It's the combination that matters here. So here, this would be like a B, and this might be a BW player, for example. There's one of them, and there's one of them. So these are not the same thing. They're not the same team. All right, we understand? So the letter combination has to be the same. So this lonely H has only got half the uniform of the other two, so they can't, it doesn't belong. Must be a different team. Now we go down to the purple scenario. Do we have any in here that seemed like they should belong? I'll use blue. Well, I've got -7AB, so wearing an apricot shirt and black pants maybe. And then we got some people over here, they have black and apricot. Look, I've just swapped the letters around. It still means the same, it's still the same color combination, they're from the same team. It doesn't matter if these letters are in a different sequence. It's just one of those things that us teachers will use as a way to sort of trick you on an exam. So just be aware of that. We can swap these letters around and it won't make a difference. They do belong to the same team because they have the same colors. It's the letter combination that matters, not the order of the letters. All right. Now you've learned to identify which terms match. Now we're going to do the process of how you gather them, which is going to make things look a bit nicer and neater. So the process is you simply sum together the coefficients. Remember, any plus or minus sign in front of the coefficients belongs to that number. So as we recall from before, these two terms belong together because they both have apricot uniforms on. And the trick I just highlighted to you earlier is that you just sum together their coefficients. So the coefficient here is a -2. The coefficient here is a +3. So if I just take these two numbers together, what do I get? -2 plus 3 gives me a +1 left over. I'll just put that there temporarily, but I really should remove it in a second. And the letter A no one's really done anything yet, so it just stays the same. Okay, so I've summed together a -2 and a +3 gives me just +1, and we know just +1 is just invisible. So one apricot person left. Because -1 has no friends right now, has no like terms to be gathered with, it just stays, it gets left alone and stays as it was. That's how we do it. Let's try this next one down. Look, I think you'll start to get the hang of it once we do a bunch of them in a row. So we got a yellow player here, and we got -3 yellow players here. So we have to sum together their coefficients. So this is an invisible 1, a +1, and we have to subtract 3. So +1 take away 3 is -2. And the letter Y comes for the ride. And the number 2 here has no friends, so it's still the same as it was before. We're going to go down to this red scenario here. We're looking for like terms, so we know that this term and this term match, but not the last letter H. This one doesn't have any friends on the field at the moment. So we have to sum together their coefficients. So we got a +7 here, and we've got a +2 over here. That should give us +9. Now remember, the plus sign is at the beginning of a sentence, the beginning of a phrase or an expression. It's invisible. So if I just write the number 9, you all automatically understand that means +9. And then we have the pronumerals, the letters come from the right. So now that we've summed together the coefficients. And this bit here, no one's done anything with it, no friends, so we just copy it as it is. Now we're going to go to this purple scenario. I'll switch back to red now. Do we have any terms that match? Yes, this term here matches. Now we just sum together the coefficients, which is this bit and this bit. So we've got -7 plus 5 gives me what answer? It gives me -2. And the letter AB that from the terms that we're gathering from, they go as is, they get brought along. I've chosen to write them AB and not as BA because the standard practice is that when you write out algebra in a term, the letters in a term, they are normally listed in alphabetical order. Now, do we have any terms here that we haven't used? Well, we have some constant terms. So a constant term is a term with no letters. Letters in algebra can often be called pronumerals, which is a weird word, But in science, a letter in an equation often is called a variable. So what do you call some part of an equation that has no letters in it, has no variables? You can probably consider them to be constant or constant terms. These green ones I've highlighted can actually be gathered together as their own thing, because we've got, if you think about it, I've got 3 people with no uniform plus 2 more people with no uniform. So surely we can gather them together. So what are the you have to consider the plus sign. So there's an implied positive 3 there, plus the 2, so it gives us a positive 5. Nice and neat. All right, I think this one here I've stolen from the exam last term, so let's see if we can try this one. Let's do, well, we can see this letter combination matches that letter combination. So we sum together their coefficients. So positive 8, take away 3, leaves me with positive 5. Yes, I think so. And then the letter AB comes as it is. Now we look at any other terms we can gather. We can gather these because these are constant terms. Oh, there's a loner out here as well. The letter B has no friends, so let's just put that in there. That way I can have just the constant term on the very end of my list. It usually looks like that in algebra, where you have all your number things. You have all your terms with letters in them, usually at the front of the line, not always. And then you have your constant numbers at the very back end of the line. I don't know why, just sometimes it usually looks like that. So now we gather the positive 7 and the positive 11, which gives us positive 18. Yeah, looks about right. Okay. Now, this one I haven't tried yet, but this is one of the questions from the exam paper on the very back. And it looks quite scary, doesn't it? But if we use the tricks that we had just learned in this video clip, you can make the problem a lot nicer if you just gather up the like terms. Now, you can't gather up terms if they're stuck upstairs in a fraction. So if there's like b plus x up there, then I can't gather the b anywhere else. I can only gather a whole fraction with another fraction, perhaps. Just be mindful of that. When it comes to fractions, and there's lots of things in the numerator, you can't gather them with people who are out of the, who are down on the ground floor. You can't do that unless you break open the fraction first, using other methods. So let's go hunting. Can we find any terms where they have the same uniform? So I wonder if there's anyone that matches this group here. So do we have anything that has b and an x? Well, we do. It's on the very end of the line, and they try to trick us because these are they're back to front. They actually do match. Okay, let's have a look at the letter X here. Does it have any friends in this list? Kind of. I can see this and this could possibly be gathered into there, so that they all share that in common. Especially if I write it like this. Negative x over 1. I think you can see now how we've got 3 fractions now where all the numerators are the letter x. And I could possibly gather those together down the road. So I'm going to highlight those 3 in green. Do we have anything that matches apricots or apples? Yes, we do. These 2 can be gathered together. So I think with my advice to the students, when you ever see a problem here that has many things in it, in a chain. I've been calling it a BOMDAS problem, but if you're from another country, you might call it PEMDAS, or in general, we call it order of operations. Whenever I encounter one of those, the first thing I'm thinking of is, can I convert anything first? Or can I shape the question into something that's nicer? So I'm actually going to go try and simplify by gathering the like terms first. When I gather the like terms, it's super important that I keep track of these plus and negative signs. They have to move together. So I might actually write this out with my pen so I can show you what I mean when I say keeping these plus and minus signs intact. that's just enough room. So we had this term, this term, this term, this term, this term, this term, and this term. So I've just made a copy with my pen, and this enables me to move. This original here is a screenshot, so I can't really move it in pieces. But when I can gather these together now, provided that I keep track of that negative sign that it came from. I can gather these together now. So I think you're starting to get the picture. So I can put all those green things together. I can put all these purple bits together. It'll be the same. It'll be the same question. Now, when I do this, can you see that there is nothing here? There's no. It looks like empty white space. I got a positive, take away, a fraction plus something, take away something, take away something, take away something. So I did make myself a little gap here. And where does that gap come from? When I'm moving things around, you do have to imagine this is actually a positive x. So that plus sign would go there. Look, I'm not suggesting that you should rearrange everything like I've just done here. I'm just giving you a visual of what things can go together. Okay, so now that I've done that, the way I would actually write this one out, I wouldn't bother trying to shuffle them around like that. Especially if I can do some of that in my head. So if we do the yellow bits first, remember we sum together the coefficients. So what is -2 take away 3? So that's getting more negative. So I should have a -5 bx. And I've listed them in alphabetical order, so I'm going to choose that way around. I haven't done anything with the x over 5 yet, so I'll leave that one alone. I don't think I can do anything with the x. I don't think I do anything with the green ones just yet. I will leave them alone for now. But I should be able to gather the purple ones together. So I just add the coefficients. So I add together positive 5.3, take away 7.6. That one's going to be a little bit tricky because I have to use my methods of subtracting with decimal numbers. So the usual process is 5.3 take away 7.6. It's going to be a bit difficult, so we need to the usual method of this is like 3 take away 6 can't be done. You borrow, so that becomes a 4. That becomes 13. 13 take away 6 gives me 7. 4 take away 7 can't be done. It'll actually give me a negative result. So I don't think this procedure works when the result is a negative answer. So I might have to just mentally just think about it. There is another trick for this, and I think I've run it before in a video, but I haven't run it with my students. Okay, so let me just write it out. So we got 5.3 take away 7.6. Okay, this is the same answer as, well, first of all, just decide, is my answer going to be positive or negative when I'm finished? A small guy, take away a big guy. I'm going to get a negative answer, which you all agree. If that's the case, now I can just worry about what's the difference between these two numbers. Okay, can I count how many decimal values there are between those two? So I can actually reverse the order. So whatever the 7.6 take away the 5.3. Don't ask me why it works. It just does, and it's a bit of a trick. So now that it's now that it's backwards, I can solve that using the method that we're familiar with. 5.3, 6 to 8, 3 is 3, 7 take 5 is 2. So the numerical difference between these two numbers is 2.3, and we know we're going to a negative direction. If you don't believe me, we can just shout on the Siri here. It's just a trick that comes in handy. I don't use it all the time. It's only for these occasions where I go, I can't really solve it the usual way. Anyway, so I've solved that part. So this will be now negative 2.3 apricots. That was the purple bit we just solved. And there's our yellow bit we solved earlier. And I think we're looking better. Oh, I haven't done anything with that fraction there, so I have to copy that one in as it is. So that x over 4. Okay. Now I think we need to, well, we can't do any further processing on the yellow or the purple bit because they are finished. They have no other terms that match them, so we have done there. All we have left to do is work with those x's, those green terms, and I think to gather all of them together, I need to make them all on the same denominator. So for starters, I'll need to put this x over 1. And now I'm looking at the denominators I've got to work with. So I got a 5, I got a 1, I've got a 4. What's the lowest common multiple of those numbers I can use such that they're all ending up on the same denominator? I can all convert them into 20. Yeah, 5 times, so if I scale this up, 5 times 4 gives me 20. So I'll do that to that fraction there. 1 times 20 just gives me 20, so I'll do that to both top and bottom. This one here, 4 times 5 gives me 20. Do the same thing top and bottom. So now my next row of working will be 4 times the x, because I've multiplied that by 4. My bottom here is 20 as per the plan. And I just copy down the yellow bit because I haven't changed anything with the yellow bit. My next term, it's going to be negative 20x over 20. And I haven't done anything to the purple, so I'm going to copy it down as it is. And then, oh, I'm running out of space here. I wonder if I can bring them a bit closer together to make some room. There we go. And the last term here would be 5x, because I've multiplied the top by 5, and the bottom's 20. Now that we look at it, these green terms should be able to be gathered. What was the process? We just summed them together, or I can shuffle the order. If it helps you sort of mentally keep track of what's happening, I can shuffle the order such that all the green terms are together. That. And remember, you can only do the shuffling provided that you are keeping the attached plus or minus sign in front of all of these terms. They have to stay attached for it to work. And it's only allowed if this chain is all plus minus, or something. It won't work if there is multiplication or division signs in between some of them. You can't shuffle them when it's in those occasions. Okay, now we just, our rules for fractions, if the bottoms all match, then you just add the tops. So what is 4x take away 20x? Okay, so 4 ex-girlfriends, and I've removed 20 ex-girlfriends. That is a good thing. We're more good. We should have 4 ex-girlfriends, take away 20 ex-girlfriends. I should have negative 17 ex-girlfriends. So negative 17 ex-girlfriends. At the moment, I want to see if I can do it all in one go, plus 5 ex-girlfriends. So I need to add 5 to this result here. So I think I should end up with 12x. 12x over 20. Let me just quickly double check that. 4 minus 20 plus 5. So if I do this and this together first, that would give me 9 take away 20. That's the same thing as, let's see, 9 take away 20, that would be, negative 11? Was I off by 1? Maybe I was. What's another trick I can do to make sure I get it the right way around? So by 20, take away 9 and put a negative around it. Yeah, so it's 10. So 10 take away 9 is 1. 1 take away nothing is 1. So it should be 11. So it should be a negative 11. Oh, what I just did now was I used this trick again. Whenever the problem is too tricky to solve in my head, like this, I use the trick where I cross them out. I don't know if it's a documented trick, but I somehow learnt it as a kid. If I swap them around, it obviously doesn't match the original answer, but if I wrap it in brackets with a negative in front, then it does match the original. So it matches these two. So what I just did now is I just did, okay, 20 take away 9 is 11, so the answer should be negative 11. So I must have been off a little bit when I tried to solve earlier in my head. Okay, so there's the green bit solved. Negative 11x, take away 5bx, take away 2.3a. And that should be it for the video. I'm just going to quickly check the answers for that exam question to make sure I haven't made a very big mistake in my working. I got the correct answer. The answer is this. All right. Hope the video has been helpful to you. I've gone over some really basic ideas. The critical thing that will make or break your success is this idea that you need to be aware that the coefficient includes the plus or the minus signs that's in front of the number. And that's what you're using as your tool to add and subtract or gather up the like terms. To gather the like terms, you will find which ones match, and you basically sum together their coefficients. So that's how we got in this, which one? That's how we got to the 9HG in that example. Thanks for watching the video.